Hi, welcome to the video guys. My name is Pushpinder Gill and today we're going to do time and work, right? And we're going to do the next part of it, that is going to be the fourth part, right? In which we will be doing the efficiency part in it, right? So this over here is our web address, that is perfect-scores.com. Do visit this to explore more about us, right? This over here is going to be our Facebook page. Don't forget to like us on this Facebook page. Show your support by liking us here. And if you have any feedback, any kind of query that you have, you can always send me at perfectscores89@gmail.com, right? So this would be the introduction. So let's start. So what are we going to do today? We're going to do efficiency, right? So by efficiency, what do I mean? By efficiency, I mean how efficient a person is to do a job, right? So you can clearly see that efficiency over here, the more efficient you are, you will take less number of days. So the efficiency is actually inversely proportional to the time that you take to finish the job. It's a simple thing. If you're more efficient, you'll take less time. If you're less efficient, you'll take more time. Similarly, efficiency is directly proportional to your, so I'm going to cut this days, I'm going to write down time here. Efficiency is directly proportional to the rate at which you finish your job. So if you're more efficient, you'll finish more rate. Your rate of doing job will be more. If you're less efficient, your rate of doing job would be less, right? So these are the two important relationships which I'll be taking forward in this video, that efficiency is inversely proportional to the time and efficiency is directly proportional to the rate. Now, as you already everyone know, that work done is equal to rate into time, right? So work done is equal to rate into time, and efficiency is inversely proportional to time and is directly proportional to rate. But there is one thing which never changes. That is your total work. Now, as I said again, that work done is equal to rate into time, right? So work done is equal to rate into time. Now efficiency is inversely proportional to time. More efficient you are, you'll take less time. It's directly proportional to the rate, but it's has no relationship to the work. Work is something that will remain same all the time. If A can finish a work in 10 days and B can finish a work in 20 days, together they finish how much work? Together they finish the work in how many days? Now what we were considering over here is we're considering total work to be the same, which is what we're going to do here, because the work will never change. So the constraint that the total work is same will remain to be the same, right? So let's show you the concept of efficiency with an example over here, right? So let me show you an example. Now, before we see an example, it's efficiency versus time. As I've already told you that efficiency is inversely proportional to the time taken, right? So let's suppose A takes, so if I say this sentence, A takes double the time to finish the job as B takes. So if A takes double the time to finish a job as B takes, then A would be half as efficient as B. Then A is half as efficient, sorry, then A is half as efficient as B. So in these two statements, I suppose you've understood this. I said that A takes double the time as B takes, and A is half as efficient as B. So it's actually correct. So I say if in terms of time taken, A is equal to 2 times B, then in terms of efficiency, A would actually be equal to, this would become inverse 1 by 2B, right? Which is true, right? If A takes double the time of B, A would be half as efficient as B. Similarly, let's show you another equation. In terms of time, let's suppose A is equal to 5B. A takes 5 times as much time as B takes. Then in terms of efficiency, what will happen to this? This will inverse. Then A would be 1 by 5 of B, right? So in terms of efficiency, this would inverse because efficiency is inversely proportional to time. I suppose you've understood that, right? So this is the main crux of everything. Efficiency is inversely proportional to time, and efficiency is directly proportional to the rate. Now let me show you a question on that. The question says that David is 50% more efficient than Chelsea. Then in terms of efficiency, what is the equation? In terms of efficiency, David is 50% more efficient. So when I say 50% more efficient, I say it's 1.5, right? So suppose you've watched the percentage video in which we say 50% more is equivalent to 1.5, or to the viewers who haven't watched the efficiency of the percentage video, 50% more means 100% total plus 50% more. So that will come down to 150%, which is equivalent to 1 by 5. So David is 50% more efficient than Chelsea. So this is in terms of efficiency, that David is equal to 1.5 Chelsea. But in terms of time taken, David would actually be equal to 1 by 1.5 of Chelsea, right? So in terms of efficiency, David is equal to 1.5 times Chelsea, but in terms of time taken, David will be equal to 1 by 1.5 times of Chelsea. Now the question says that if David takes 10 days to finish a job, then Chelsea will take how much time to finish the job? Now the question says David takes 10 days to finish a job. That means the value of time taken by David is equal to 10. Now if I insert this into this equation over here, I will get 10 to be equal to 1 by 1.5 CT, and I will get the time taken by Chelsea to be equal to 15 days. I'm going to repeat the question once again. The question says that David is 50% more efficient than Chelsea. That means in terms of efficiency, the equation of David and Chelsea would be David is equal to 1.5 into Chelsea. However, in terms of time taken, this would inverse. So when this inverse, the time taken by David would be 1 by 1.5 of the time taken by Chelsea. So in that case, the question says that the time taken by David is 10 days. So this over here comes down to be 10. That means the time taken by Chelsea is equal to 15. Now what concept are we using here? We're using the same concept. That if in terms of efficiency, David is 1.5 times Chelsea, then in terms of time taken, David would be 1 by 1.5 times Chelsea. This is the concept that we are using because we know that efficiency is inversely proportional to the time taken. Right. So I suppose everyone has understood this one over here, right? Let's make it a little bit more tough, right? Now the question says that Andrew is thrice as good as workman as Ben. That means I'm going to write down my efficiency equations over here. So let's write down our efficiency equations. That Andrew in terms of efficiency is 3 times as good as workman as Ben in terms of efficiency, right? Then in terms of time taken, since efficiency is inversely proportional to the time, in terms of time taken by Andrew would actually be, so instead of 3, what will come here? 1 by 3, right? 1 by 3 of time taken by Ben. Now the question says that therefore Ben is able to finish the job in Andrew is able to finish the job in 60 days less than Ben. That means the time taken by Ben minus the time taken by Andrew is actually equal to 60 days, right? So time taken by Ben minus time taken by Andrew is actually equal to 60 days. And we already know that from here, that 3 times time taken by Andrew is equal to time taken by Ben, right? So if I substitute here, that would be 3 times time taken by Andrew minus time taken by Andrew is equal to 60, which means 2 times time taken by Andrew is equal to 60. That means time taken by Andrew is actually equal to 30. Now what is the question asking? The question is asking working together they will finish the job in how many days? So time taken by Andrew is 30 that would mean time taken by Ben over here would actually be equal to 3 times 30. That would be equal to 90. Okay, so Andrew finishes the job in 30 days and Ben finishes the job in 90 days. So this is the number of days which are there, right? So now it becomes an easy question for us. So what will I do is I'll assume the work to be of 90 units. Let's say the work is of 90 units. So the work will become of 90 units and the work will never change, right? Now, when we find the rate, A finishes 90 units in 30 days. That means he finishes 3 units per day. And B finishes 1 unit per day. And together they're going to finish 4 units per day. So together they're finishing 4 units per day. For them to finish 90 units, they're going to take 90 by 4 days, which is going to be equal to 22.5 days. Right? So this over here is my answer. It's actually quite a lengthy question, but very easy. It says that Andrew is thrice, he is thrice as good as a workman as Ben. So over here we got to know that if he's thrice as good as workman as Ben, that means he'll take 1/3 the time taken by him. And the question says that. So the time taken by Ben over here is equal to 90 days, and the time taken by Andrew is equal to 30 days. Then we simply went on with the rate chart method. I assumed the work to be of 90 units, and I calculated how many days in total it will take them to finish the job. Right now, I can show you. We can do these kind of questions in a very, very, very fast way as well. But that is not safe. So I want you to go with the safer method rather than a faster method. So always approach a safer method rather than a faster method, because a safer method, the chances that you won't get it wrong are quite high in a safer method. So we would aim for accuracy rather than time, because time is something which will eventually come if you're following the right technique, right? So I suppose you're understanding my point where I'm coming from. So let's move forward. All right, so let's see this question. So this question says that Andrew can finish a work. So Andrew can finish a work in 20 days, while Daniel, working alone, finishes the same job in 25 days, right? So the question is asking Andrew is what % more efficient than Daniel. So this over here is your time. Now, we can calculate the efficiencies in terms of time as well, but as you know that efficiency is inversely proportional to time, but efficiency is directly proportional to the rate. So if you're able to calculate the rates, we'll be able to calculate answer much easily, because we naturally are very comfortable with things which are directly proportional rather than being comfortable with things which are inversely proportional. This is something which is natural in all of us. So if Andrew takes 20 days to finish a job and Daniel takes 25 days to finish the job, let's say that the total work is of 100 units. I'm just taking the LCM of these numbers. Let's say the total work is of 100 units. Now what we're going to do is we'll be finding the rate. Okay, so if the work is of 20 days and the total units are 100 units, that means he's going to take 5 units per day, right? Similarly, Daniel is going to finish 4 units per day, right? So Andrew finishes 5 units per day and Daniel finishes 4 units per day. Now the question is asking Andrew is what % more efficient than Daniel. So Andrew is what % more efficient than Daniel. So the question is basically asking 5 is what % more than 4. So this is what the question is asking basically, because now we are going with things which are directly proportional. So 5 minus 4 divided by 4 into 100, right? So this over here will give you, so which would be equal to 25%, right? So suppose you've understood that what I've done over here. The question says that Andrew can finish a job in 20 days while Daniel takes 25 days to finish the same job. I asked Andrew is what % more efficient than Daniel. So instead of going by inversely proportional things, we went with directly proportional. So we assumed the total work to be of 100 units. So if the total work is of 100 units and Andrew takes 20 days to finish the job. That means he's going to finish 5 units per day. And if the total job is of 100 units and Daniel takes 25 days to finish the job, that means he's going to finish 4 units per day. So the question is asking Andrew is what percent more efficient than Daniel. See, it's asking percent more rather than percent off, right? So Andrew is what percent more efficient than Daniel. He's one more than him in terms of percentage. That came out to be 25%, right? So let's suppose you've understood this question over here, right? Let's move forward. Okay. All right, guys. So this question says that A and B can finish a job in 12 days. B and C can finish the job in 15 days. And then he gives something about the efficiency. Okay. So let's set up a scratch paper here. It says A and B can finish the job in 12 days, right? So this is the time here. A and B can finish the job in 12 days, right? Then the question says about B and C. B and C together can finish the job in 15 days. So what will I do is since I know that efficiency is directly proportional to the units, I would rather find the rate rather than, going for time. So if I assume the work to be of, let's say, 12 and 15, 60 units. If I assume the work to be of 60 units, then what will I do is I will go ahead and calculate the rate. That means he's going to finish 5 units per day and B and C are going to finish 4 units per day. Okay. All right. So from here, we come to know that A plus B is actually equal to 5 and B plus C is actually equal to 4. Right. Now the question says that if A is twice as good as workman as C. Now see, this is the these are the equations of rates. So the equation of rates would be equivalent to the equations of efficiencies, because efficiency is directly proportional to rates. I think we established that in the very beginning of this video. So this would be the ratio of efficiency as well. And there is one more thing that this question is saying, that A is twice as good as workman as C. That means A is twice as good as workman as C. So this is what is given in the question. So we have these three set of equations from which we have to calculate the answer, right? So A is equal to 2C. So what will I do is I will substitute the value of 2C here. So what will happen is 2C plus B would be equal to 5 and B plus C would actually be equal to 4. So if I subtract both the equations, what will I get? I will get C to be equal to 1. So if C is equal to 1 and A is equal to 2C, then A would be equal to 2. Now if A is equal to 2 and A plus B is 5, that means B would be equal to 3. Right? So we have calculated all the figures here. Now these are nothing but the rates as well. Now the question says how many days will B take to finish the same job. So B finishes 3 units per hour, right? So B over here finishes 3 units per hour and the total work is of 60 units. That means B is going to take 20 days to finish the same job, right? I'm going to repeat once again all over again here. Now this question says that A and B can finish a job in 12 days and B and C can finish the job in 15 days. So what did I do is I assumed the work to be of 60 units. Then the rate came down to be 5 here and the rate came down to be 4 here. Then A plus B is 5 and B plus C is 4. Understand that efficiency is directly proportional to rates. So the rate equation would be equal to the efficiency equation, but not the time equation. So I would say A plus B is 5 and B plus C is 4. And the question says that if A is twice as good as workman as C, that means A is equal to 2C. So I have these three equations and I have these three variables. So what did I do is I went ahead and solved all these three. I got the rates of C, A and D. Now the question is asking how many days will B alone take to finish the same job. If B finishes 3 units per hour, for B to finish 60 units, it is going to take 20 days working at this rate, right? So I suppose you've understood this one over here. the confidence that you get with these techniques would be that you will say that I will be able to solve each and every question. That is the kind of confidence that I want to give you guys. No matter what question on rates you put me, until and unless I'm not making any calculation errors, there will never be a question that you will not be able to handle, right? So this is some confidence that I want to give you, no matter what kind of test is this, right? So that is that, right? So I suppose you've understood this one. Moving forward, all right. Now, till now, we've been dealing with efficiency in individuals, right? Like A is working, B is working. And now let's see about efficiency in groups, right? So how do efficiency in group matters? So I'm going to solve a question out for you over here. That is going to make things much clearer. There's very, very less difference. The difference is very, very less, but still there is a small bit of things that you have to take care of when it comes to efficiency in groups. Okay. All right. Now the question says that each worker in city X is 50% more efficient than each worker in city Y. So each worker in city X is 50% more efficient. So I'm going to say 50% more to be 1.5. I suppose till now everyone understands that 50% more means 150%, which is 1.5. So 50% more efficient than the worker in city Y. So this is in terms of efficiency. This over here is the equation, right? So this is there. Now the question says that if 10 workers from city X and 8 workers from city Y can do a job in 22 days. Now this is in terms of efficiency, which would be same in terms of rate as well, isn't it? Which would be same in terms of rate as well, that the number of units finished by any city X worker would be 1.5 times the number of units finished by per hour by any city Y worker. So the question over here says that 10 workers from city X and 8 workers from city Y, right, are able to finish the job in 22 days. Okay, it's able to finish the job in 22 days. Now let me make one assumption. Now this is an assumption that you have to make in groups all the time. You have to fix one of the group. Now I'm fixing X group of people. Let's suppose every worker from city X in one day finishes 1 unit of job. I'm making this assumption here. Let's suppose every worker in city X in one day is finishing 1 unit of job. That means in one day 10 workers will be finishing 10 units of job. And similarly over here, every worker from city Y. Now, okay, I actually made it, I can actually make it a easier number. Instead of 1, let's say every worker from city Y finishes 1 unit of job. Just not to have anything divided by 3 here, which is why I'm keeping every worker from city Y is finishing 1 unit of job. So every worker from city Y is finishing 1 unit of job every day. That means in one day, 8 workers from city Y will finish 8 units of job. Now what about X? Now if I say every worker from city Y in one day finishes 1 unit of job, then every worker from city X in one day would actually finish 1.5 times the number of units finished by worker Y, which is 1.5 times Y, which is going to be 1.5 units of job. So every worker from city Y in a day finishes 1 unit, and every worker from city X in a day finishes 1.5 units. That means 10 workers of city X every day are going to finish 10 into 1.5, which is 15 units of job, right? So this is what every day all the 10 workers are going to finish. That means every day how many units of work are going to get finished? That would be 15 plus 8, which is 23 units are getting finished in 22 days. So 23 units every day are getting finished, and that is going on till 22 days till the job is finished. So what is my total work now? My total work would be the total number of units. So every day 23 units are getting finished, and this is going on for 22 days. That means my total work would be equal to 23 into 22, right? So which is the rate into time, that's the total work. Now this over here is my total work. That's what I have to do. Every time I have to calculate the total work, right? Now what's the question asking me? The question is asking me, in how many days will 8 workers from city X and 10 workers from city Y will finish the same work, right? So this is the same work, and how many workers from city X? 8 workers from city X and 10 workers from city Y. So every day, so in one day, how many units do they finish? That is what we have to find out. Now every worker from city Y finishes 1 unit. That means 10 workers from city Y are going to finish 10 units. Now again, every worker from city X finishes 1.5 units every day. That means 8 workers will finish 1.5 into 8, right? So that would be 12 plus 10, which would be equal to 22 units every day they are going to finish. So if the rate is equal to 22 units every day and the total work is this, that means the time taken by them into the rate, which is 22, would actually be equal to the total work. That means the time taken by them is equal to 23 days. Tricky question, right? But see the simplicity with which we are solving this. All you have to do is, you don't have to deal with variables and all those things. You can just assume your own chart, and this is what you're going to do in every question. I'm not saying it's specific to this question, but every question you'll be doing this when it comes to that, right? So it's again, I'm repeating. So the question says each worker in city X is 1.5 more 50% more efficient than each worker in city Y. I just assume that every worker in city Y finishes 1 unit every day. Then every worker in city X will finish 1.5 units every day. Now the question says that 10 workers from city X and 8 workers from city Y are able to finish the whole work in 22 days. That means so the total work they finished. So 8 workers from city Y finished 8 units, and 10 workers from city X finished 15 units. They totally finished 23 units every day, and they worked for 22 days. That means the total work is equal to 23 into 22. Now the question asked me that 8 workers from city X and 10 workers from city Y will take how much time to finish the same work. So 8 workers from city X will finish 12 units every day, and 10 workers from city Y will finish 10 units every day. That means totally they're finishing 20 units every day, and for them to finish this many units, it is going to take, now time into rate is equal to work. This is what we are again following here. That's the universal equation. Work done is equal to rate into time, and I just put that there, and I got the total time taken would be equal to 23 days, right? So suppose you've understood this question over here. Let's move on to the last question. Okay, all right. So let's see this question over here, guys, right? So the question says that David can do a piece of work in 20 days working 7 hours a day, right? So David over here is able to finish the work. So the time taken by David is 20 days, and the rate for David is and he works 7 hours a day, right? So the time taken by them, so I'm just going to calculate the total time in terms of hours. He finishes the work in 140 hours. That's what the total time taken by David is, right? So I'm going to write David here. Okay, so the question says the work is started by David, and on the second day, one man whose capacity to do work is twice that of David joined. And on the third day, another man whose capacity is thrice that of David joined. And this process continues till the work is completed. So in how many days will the work be completed, right? So let us say that the total work, this is something that you have to do every time, guys. You have to assume the work. Let's suppose the total work is of 140 units. This is the total work. So if David finishes the total work in 140 hours, that means he finishes 1 unit every hour. This is what his rate is, and this is my total work. So the question says that the work is started by David. So in the first day, what happens? First day, when David works for 7 hours, he finishes 7 units. So this is what happens on the first day. On the first day, so this is the day, these are the units. So in the first day, what happens? David finishes the 7 units. On the second day, what happens? David will finish his 7 units. However, there will be a person on the second day, one man whose capacity to do work is twice that of David joined. That means that person is going to finish double the number of units finished by David, which would be equal to 40. I suppose you remember that efficiency is directly proportional to your rate. So if David finishes 7 units, someone who works twice of its capacity is going to finish 14 units. So that would be equal to 21. Now again, on the third day, what is going to happen? On the third day, there will be 21 units finished, plus on the third day, another man whose capacity is thrice that of David joined. That means that is going to be 7 into 3, which would be 21, which is going to be equal to 42. So the question says that the process continues. So on the fourth day, it's going to be 42 plus there will be a person joining, which is 4 times the capacity of David, right? So this is what the question would be. That would be 4, so twice, thrice, so it would be 4 times. So that would be 42 plus 28, right? So if I add 42 and 28, what does it come down to be? That comes down to be 70, right? Then what is going to happen on 5th day, right? On 5th day, there would be 70 units finished, but someone with 5 times the capacity of David is going to join. So which will come down to be 105 days. Now let's see what is happening, because our answer options are 3, 4, 5 and 6. So I've reached till 5 and the total work is of 140 units. So 7 plus 21. So I'm going to write the cumulative over here, how much work is getting finished. So first day 7 units, second day 21 plus 7. So 21 plus 7 would be 28. On the third day there would be 42 plus 28. So 42 plus 28 is going to be equal to 70. But on the fourth day, as you can see, 70 units are finished and 70 units are finished here. On the fourth day, 140 units will get finished. That means it will take 4 days for the job to get finished. I need not to calculate the fifth one. I could have had the cumulative work with me all together all the time, right? So suppose you've understood this question, what we're doing over here, we're actually again following this, that efficiency is directly proportional to the rate. So if day 1, 7 units are getting finished, day 2, 7 units plus double of 7, day 3, 21 units plus triple of 7, 4 times 7, and then when we added the total work, it actually matched the total work on the 4th day, and it's gonna take 4 days for David and his company to finish the job, right? So suppose you've understood this question, right? So it's actually a difficult question, but the simplicity with which we solve this question is what matters here, right? Okay. Great, guys. So I suppose you've understood. If you have any feedback on this, if you have any doubt on this, please send me an email. I'll give you a reply. Okay. All right. So thank you very much for watching this video. So this was time and work 4. This was the efficiency part, right? So make sure that you practice on this, right? So make sure that you practice, because practice is something that will make you more than perfect, right? So what to do next? This was the time and work efficiency part. There are still few things left, like in the time and work topic, if you want to exhaustively cover it, like distribution of money and small things, but pretty much that finishes the time and work. The basic concepts which are required, and make sure that you watch the other videos as well. This is where that you explore more about us, right? This is where you like us and the community and everything, and this is where you give us feedback, right? Don't forget to send me your valuable feedback, guys. So this was about the video, guys. Thank you very much. Thank you for being such an awesome audience. I'll see you guys in the next video. Bye.